Hello everyone, we got a GRE physics problem here to solve. It's in classical mechanics, and in this problem we are given a thin uniform rod of mass m and length L as shown in the figure here, and this rod is positioned vertically above an anchored frictionless pivot point here, this one, and this rod is then allowed to fall to the ground, and it is asked with what speed will the free end, this end of the rod, strike the ground. And our answer should be one of these five options: A, B, C, D, and E. Now, this problem can readily be solved by applying the law of conservation of energy to the falling rod, considering the ground as the reference point for the potential energy. The potential energy of the rod in the vertical position will be totally converted into the rotational kinetic energy of the rod upon reaching the ground. Since the rod is uniform throughout, its center of mass lies exactly at its center, which is L by 2, that is length of the rod divided by 2, above the ground in the vertical position. And this allows me to write down the potential energy of the rod equal to m, mass of the rod, times g, acceleration due to gravity, times L by 2, which is height of the center of mass of the rod above the ground. And this potential energy will be totally converted into the rotational kinetic energy of the rod as the rod comes down and hits the ground. So let us equate it to rotational kinetic energy, half I omega squared, where I is the rotational moment of inertia of the rod about the pivotal point here at the end, and omega is the rotational velocity of the rod as it hits the ground. And this equation will give me the speed of a point at the end of the rod when the rod strikes the ground. So let us simplify this equation further. This gives me m times g times L. Of course, half and half cancel out on both sides, and I am left here with I omega squared on the right, and I for the rod about its end point is given by 1 by 3 times its mass times its length squared, and of course here omega squared. You see mass of the rod cancel out on both sides, and I am not cancelling L out on purpose because I know speed of a point at the end of the rod is given by V is equal to length of the rod L times omega, that is the angular velocity of the rod. So this equation gives me G L is equal to 1 by 3 times L squared omega squared is now V squared, that is speed of a point at the end of the rod when it strikes the ground. So from here V is equal to 3 times G times L under the square root, and this is the correct answer, option C here. Thanks for watching, guys.